Thank you for that. Yeah, so as I was saying, as the Earth is slowly moving on its axis, we've moved from Europe to North America, and now we're on this continent. So I think the rest of the speakers are here, but we do have one further talk that is beaming in, and it's my great pleasure to introduce Judy-anne to give a very special talk about Richard as a role model. So Judy-anne, take it away.
Thank you so much, Alex. And thank you, Alex and Nathan and Tim and Tony for organising this day. So Richard Brak was my PhD supervisor, as I'm sure all of you know, and I think an amazing role model for a young academic, or really for any academic. And I'm going to talk a little bit about that today. So he taught me so many things. I don't think he ever said, I'm going to teach you something now. It's a real apprenticeship model. But one of the first things that I personally learned from Richard, I think, is how to give a talk. And I've seen lots of talks by people who never learned how to give a talk. And I'm hugely grateful. He was a most amazing communicator in so many ways, and I hope I really am his student in this. Starters, he always had beautiful slides. I know, I expect you've all seen people give talks with slides cluttered. Nobody here seems to do it. There seems to be something in this community that's amazing. But there certainly are a lot of talks out there that it's like a novel to read. It's impossible. But Richard's slides are always beautiful. I went looking for slides, and I found a relatively recent talk he'd given at Monash University on a topic very dear to my heart. And it's about these beautiful Catalan objects. So we all know dick paths and bracketed things and binary trees and chorded circles and triangulated polygons and hundreds and hundreds of different families counted by this wonderful counting sequence. And he would always tell a beautiful story and introduce his talks really, really well. These sparse, lovely slides, just a few bullet points with really elegant pictures, just utterly intriguing. And he thought and communicated in pictures, in so many ways, but in particular in pictures, and just so many examples amongst his work of pictures. And I picked this quite simple one because it relates a little bit to the previous slide. We all, almost all here in this group, know and love dick paths. Just such a simple idea. Yes, no, yes, no, yes, yes, no, yes, yes, no, no, up, down, up, down, up, down. Such a, elementary idea, and such richness in it when you just pull it out, stretch it out in time and look at it and think about it as a physical model for something, or about voting patterns, or about, you name it, so many things that this can represent. And this is from an old paper with his friend John Essam that he worked with a lot, and just taking all of this delicate detail and chunking it in the psychology sense of chunking it. Okay, there's a wiggly little bit there that starts and ends, and here's the last point where it ends on a given height. So there's a chunk. Here's my chunk. And pictures which are so evocative and which lead you from story into algebra and back again. And we saw in Thomas Prellberg's talk and some of the earlier talks, this factorization leading to generating functions. Andrew, yes.
I can't see your updating slides. It seems on the
whoa, okay.
maybe
Can you,
maybe an internet. I just see the title page.
Oh my goodness, thank you, Andrew. So Alex, maybe we do need you to share slides for me.
Okay. So,
Unless I share in a different way.
I will talk. That one? Yeah. Okay.
I think we sent about 3 versions, so you want the most recent version.
Yeah, but the only version I've got, so.
All right. I'll fly with it.
Yeah, that's right. Yeah.
So I can't see it yet, but let me know. Ooh.
Okay, so you should see it now, Judy-anne.
I do.
Okay. All right,
Thank
you tell me when to go next.
All right, so let me do a little recap. Richard Brak, as you know, gave beautiful talks and beautiful slides, sparse, elegant slides with pictures, slides that told stories. Next slide. And he thought and communicated in pictures. And here's this picture from a paper with John Essam, and you can see our beloved dick paths or ballot paths wiggling up and down, yeses and no's, ups and downs. And they model so many different things when you think about them in different ways. And all these little wiggly bits somehow chunked together in these little blobs to make this factorization, which then leads to a way of thinking about it algebraically and getting generating functions and getting physics and getting all of this stuff out of it. Next slide, please. So I didn't really think anything of it at the time. I liked pictures, he liked pictures. I thought everyone did that. In this community, maybe everyone does that. But actually, looking at it from a bit of a broader perspective, not everyone does that. So just to give a bit of my own personal trajectory. So I went from my PhD at Melbourne University to a postdoc in computational maths at ANU to a postdoc at CAMA at Newcastle, Computer Assisted Research Mathematics and its Applications, with the late Jonathan Borwein. And he was another big thinker about mathematics and the nature of mathematics. And nearly every talk he gave, he used to quote this, well, maybe not nearly every talk, but a lot of his talks, he used to quote Littlewood. He used to say, a heavy warning used to be given by lecturers that pictures are not rigorous. And this has never had its bluff called and has permanently frightened its victims into playing for safety. Some pictures, of course, are not rigorous, but I should say most are, and I use them myself wherever possible. And I really love that quote by Littlewood. And it's really pointing towards a sort of an interesting sociological phenomena where somehow there's this idea that if something's algebraic and not that pictures are somehow a little lower class. And they're not. And so I was sort of free from that bias by having grown up mathematically under the guidance of Richard Brak. So I'm really grateful for that. Next slide, please, Alex. Another thing Richard always did is he gave really accessible examples. So this is from this same talk that I found in the Monash seminar talk series of Richard had given this talk in 2018. And here are our beloved dick paths, the there's 5 of these paths of length 6, and these are your options. So you're stepping north, east or southeast, and you're never going below a certain baseline. And when you figure out all the wiggly little possibilities, there's these 5 of them. And when you're getting to longer and longer, of course, as the majority of this audience knows, the more work it is to try and figure out, have you really got them all? And so it's great to have a systematic way of generating them. And this defactorization that was in the earlier slide says, well, if you've got one of these wiggly, bumpy, up and down sort of things, well, it consists of a wiggly, bumpy, up and down sort of a thing, or maybe just a dot, and then an up, and then more wiggly, bumpy, up and down, and then a down. And that second wiggly, bumpy, up and down thing might also just be a dot. And then you build up your longer paths by systematically considering all combinations of relevant shorter length paths to get the paths of the given length that you're interested in. And it gives you algebra, and it gives you generating functions and everything, as we saw before. But the thing about this example, and every Richard example, I think, is that you don't have to have some massive amount of background to start to see this, because it's visual. You can, your brain wants to make these connections. You start going, oh yeah, well, if I put this there, well, how does that work? And it's a way in, it's a hook. And it was something that he did beautifully in every talk. And next slide, please, Alex. So I'm going to make an aside. I shall note in my own trajectory going from ANU to CARMA, I then got a continuing job at Newcastle. So when I was hired at CARMA, I was hired as a combinatorialist with a computational bent. When I was hired as continuing staff member, it was to bring that research element to the teaching, and as a teaching sort of specialist. But there was another really wonderful teaching specialist there called, it's not, teaching specialist has got the wrong connotation, but as someone with expertise in that area. And Malcolm Roberts was another staff member there who had a great deal of expertise in that area. And he noted that one of the best motivations for learning is achievable challenge. It has to be challenging. It has to be something that you just can't see in an instant, that it takes work, but is doable. Next slide, please, Alex. And when you get that, when you understand, there's this little pleasure hit goes off in the brain. And so I put here this little brainy dingbat, which was one of Richard's many artistic creations that adorned the Gazette in one of its incarnations. Next slide, please, Alex. Yeah. And the other thing about Richard's examples is they're always highly suggestive of analogies. So taking that same talk, that same paper, you can see what he's done with dig paths on the right, decomposing a dig path in a product formulation where your generator, your basic element is just a dot in that case, and comparing with what's happening on the left, which is these polygon triangulations, so counted by the same counting sequence, 1, 2, 5, 14, etc. There are 5 of this particular size, and breaking it up into a certain product with a certain generator. And then you can play those same games and gradually build up your bigger and bigger examples. And you see it, and you see the orange and the blue on the left and the orange and the blue on the right, and that structure and that similarity. And you just want to bring them into relationship in your mind. And that was the whole point. And the point of the talk in that paper was that if you've got some lovely Catalan family and some other lovely Catalan family that looks totally different, if you can figure out a product formulation for each of them, then you can make a bijection that's more than a bijection. It's a homomorphism by taking your object, let's say your triangulation, and breaking it down by undoing the product, then translating across to the Dick path world, and then building it back up again by reapplying your product. And voila, you have your bijection in a way that is in some really lovely sense natural, and that's preserving loads of the structure and Narayana statistics and things like that as well. Next slide, please, Alex. So this is also not just some random little thing. Neuroscientists who study foundations of mathematics claim, at least Lakoff and Nunes do, and others, that maths in some sense is built on analogies, and bijections are a special kind of analogy. Very special kind of analogy. The whole structure, the whole shebang, underpinned by set theory, if you like, is built neurologically and physically on analogies. So sets are like containers with objects in them, and containers with objects in containers in objects, and so on. So it's a really fundamental thing, and Richard's such a great communicator of that in the visual way that he spoke. Next slide, please, Alex. He also really appreciated effort. I remember I was Richard had noticed that if you took dick paths and you put them in a banded space, so that you labeled edges that happen to fall in odd bands with S1 and edges that happen to fall in even bands with S2, if you labeled them this way and produced a generating function that was broken down in that more detailed way, that you got Narayana numbers coming up, and that the exact same thing happened when you counted dick paths according to peaks and valleys. And so he was thinking there should be a bijection. Why don't you go look for a bijection, Judy-anne? And I was also thinking there should be a bijection. And I was wondering more generally, more philosophically, will there always be a bijection between two objects that families of objects that are counted by the same sequence of counting numbers? Is there a sort of, because of course there's always a bijection in the sense that if you can count one set and you can write it out in a list, and you can count the other set and you can write it out in a list, then you can just match those lists together. But was there some sort of fundamental basic way to get from one to the other? I was really interested in that, and I was trying to figure this out, and paths of length 6, they're too short. I was doing paths of length 8 and 10 and 12 and doing it by hand and sticking together A4 sheets to make A3 to make A2 to make these great long reams, and carrying up these reams to his office and holding them up against the wall. I remember Andrew Recknitzer coming in the office, and I'd done all this stuff, and Richard saying, she's outdone either of us in terms of detailed hand calculation. Just trying to fix, going, well, this one's sort of wiggly here, and surely it relates to this wiggliness over here. What's trying to feel the similarity between the two? Yeah. So this particular picture is printed stuff from my thesis from after I found found a bijection. But at the time, and Alex, next slide. Thank you. At that stage, I didn't actually have any solutions. And, somebody else might have said, well, you've done a lot of work, but you haven't actually got an answer. But what I got from Richard was, just she's outdone either of us. And that was an amazing way to work together. This is the what used to be the Richard Berry building. I think it might have been renamed Peter Hall building. what I think of as the back entrance, although it's the more ornate one, but it's further away from Richard's office. But if you go in this door and you turn right, you go straight ahead on this hallway, you come up to these sort of double pillars, and then behind that there's these double stairs that lead up to a landing in the general stat-mechy area of the world. And you know, I often didn't have any solutions, but next slide, please, Alex. But I would go tearing up those stairs just nearly as quick if I didn't have an answer as if I did. And if I had something, I'd explain it. And then in explaining it, it would get better. And if I didn't have something, then I'd explain the fact that I didn't have something. I'd explain what I didn't have. Like, I want this, but I don't have it. If I had it, it'd look like this. And that somehow always led to getting somewhere. It was wonderful. Next slide, please, Alex. And if per any chance I just fell out of communication for a little while, there'd just be this little low-key email, just how's things? And then I go tearing up those stairs again to go, oh, well, I haven't figured anything out. But what I'd like to figure out is just really gentle. Next slide, please. And Richard, I mean, he was so busy, but he always had time for me. I don't actually remember whether we made set appointments or whether I just randomly turned up or whether it was some combination, but it didn't seem to matter. He always seemed to have time, and I'd be come into his office, and, you know, he was busy, and other people would, you know, frequently come along. We'd be meeting about whatever, and we'd be talking, and then sometimes we'd be just sitting back and thinking a little bit, and it's talking, and someone would knock on the door and they'd need something, and Richard would solve their problem, and they'd have a question, and Richard answer their thing, and they'd need something, and Richard would take a stonking great printer and print whatever he needed, just like, yep, Richard's solving somebody else's problem again. Actually, I remember one meeting that was surprising, because normally it was StatMech people, but there was this one meeting, Swarup Gade knocks on the door and says something cryptic. Okay, and then Alex comes in and says something cryptic, goes down, then Swarup's back and it's something cryptic, and I was like, dear, Swarup's from like a whole different research area, different part of the building. I figured out what it was. It was a cricket. There was a super important cricket match on, and this is coded information. But he just managed to interleave the needs of his colleagues and joy, and always had time. Next slide, please, Alex. And Richard did what I think any PhD supervisor should do, which is inducted me into his community. You know, I know PhD supervisors who'll tell their students, oh, I'm not going to be around for the next 2 weeks, so, you know, amuse yourself or whatever, and not mention that they're going to the OSTMS conference, or that the OSTMS conference exists, or that people should go to conferences or anything like that. But Richard was always really inclusive, inviting people into a network, into a world that I'm so glad to be part of. Next slide, please, Alex. And he gave me heaps and heaps of tacit knowledge, like, okay, so you go to 2 conferences a year, OSTMS and one specialty. This one's the specialty. That was at that stage the annual StatMech meeting, which would have become ANZAMP now. Next slide. And I remember being at those conferences, and I think the first one, I was just wondering, and I saw Richard, and I was thinking, and he was surrounded by students, like this solid annulus of students. I think all the other professory types were off doing professory things with themselves, but Richard, I think, had every student from the whole conference around him in this like 3 or 4 dense, packed thing. And it's like, I'm lucky I'm completely prepared, and there's help with everything I need, because there's just no way I get through that pack. And just looking at it and thinking, you know, because he really listened, or he saw people, just his enthusiasm. Next slide, please, Alex. And he was interested in everything. I mean, just about everything. I was just looking around in the shed for nails and screws the other day, and I found a nail with a curvy spiral on it. And it reminded me instantly of Richard telling me one time that he'd been watching this really cool documentary about this guy that had invented a particular type of nail. And he said, you know, the trouble with nails is they're not spruce. And when a big storm comes along, there goes your roof. He was just interested in everything. Next slide, Alex. And, you know, in little vignettes in between maths, we talked about, you know, bird watching and art and his mum's art gallery and the difference between fire in South Africa and Australia and Aboriginal fish traps, because I found a book on it in the National Gallery. And he's going, so yeah, they did, and archery and swimming and you name it. Model of a complete life. Next slide, please, Alex. And we would talk about creativity, and he would say, you know, I don't believe this stuff that you get less creative as you get older. I think there's just more crap that gets in the way. And he, you know, made efforts to try and avoid that crap getting in the way of a creative life. And you know, he avoided seeking more money or promotions or that sort of thing, just in order to keep that creative space. Next slide, please. And he was creative in so many ways and gave to community in so many ways, and creative in maths and art and archaeology. The bottom picture is from the website, I think Gnosis, a recreation, a 3D creation that you can walk through of archaeological sites, and Nathan can tell you more about that. So beautiful. Next slide. And he just appreciated people. It was just so lovely to see Richard greet Alex, to see, next slide, Alex, to see, oh, now this is the, in my other version, I had photos from Dunk Island, photos of so many people, Stu and Murray and Chris Soteros, and the warmth with which he would say those names, Tony, the appreciation that he had. You know, he would say, you know, Tony and Frank, they are leaders. He valued community. He contributed enormously to community. One of the criticisms that I think is justly made of academia is it's kind of a bit hyper individualistic. We tend to lionize genius and say genius will out no matter what, and not see how community supports discovery and individuals and stuff like that. And he was just a counterpoint to that. He gave all the time to his creativity, his artisticness. He valued other people. He was a wonderful example of how to be a person with integrity and care and joy. And we're lucky to have his legacy, his maths, his art, the photos that show how he saw the world. Next slide, Alex. I think I'm just about on time. This is a picture he took of me in London. I was lucky enough to visit him and his sister in London one time. And the proper final version of this talk said goodbye, Richard, and thank you. That's it. Thank you.
Well, as you can hear, Judy-anne, very appreciative audience of your beautiful talk, and I think the passion with which you displayed is a passion we also remember in Richard. So he certainly have that that you've got. I don't know if it is. If someone has a question. I don't know if or
Alex, there's a question. Can we see slide 2? So if you would go back to slide 2.
Slide 2. I can do slide 2. I can give any slide, really.
No. Slide 2.
Has anyone online or in the audience here got a question? I don't think so, but I don't think questions are really needed. Thank you so much, Judy-anne. That was beautiful.
Thank you, Alex.